Welcome to 15.C, the product rule. We're going to be looking at investigation number 3. I would like you to actually take a copy of that investigation, which I've placed on the website to make things easier for yourself. Okay, we're going to start with this investigation. Suppose we have u of x and v of x, and they are two functions of x, such that f of x equals u of x multiplied by v of x. In other words, these two functions are multiplied together right here. The purpose of this investigation is to find a rule for determining the derivative of something that looks like this. All right, so number 1. Suppose u of x equals x and v of x equals x. So f of x would equal x squared. Okay, so we're thinking if we substitute it in, we know f of x is u of x times v of x. And if u of x just equals x, so that's x. If v of x just equals x, that's multiplied by x. In other words, that's x squared. So that's where this comes from. Find the derivative by direct differentiation. In other words, from this, we know that the derivative here is 2x. Okay, find the derivative of u and find the derivative of v. We can do that. We know that if u of x is x, then the derivative of u is just 1. Similarly, if we know that v of x equals x, the derivative of v is just 1. So, if we think about it, can we answer this question? Does the derivative of f equal the derivative of u multiplied by the derivative of v? In other words, does 2x equal 1 times 1? Absolutely not. No, doesn't. Okay, so we've answered number 1. Number 2, suppose u of x equals x. V of x is the root of x, so that when we put those together, multiplying them like up here in our function, we're saying that it's x multiplied by root of x. Here it is. In other words, we could say x to the power of 3 over 2. Find by direct differentiation the derivative of f. Okay, so we're talking here. The derivative of f would be 3 over 2 x to the power of 1 over 2. Decrease that fraction by 1. Find the derivative of u. Well, this would be 1. Find the derivative of v. Well, v of x is x to the 1/2, changing it to an exponent instead of a root sign. Therefore, the derivative of v would be 1/2 x to the power of negative 1/2. Okay, and again, does the derivative of f equal the derivative of u multiplied by the derivative of v? No, it does not. Okay, so here we're asking, does 3/2 x to the power of 1/2 equal 1 times 1/2 x to the power of negative 1/2? Absolutely not, no. All right. All right, we're going to take a look at filling out this table. Copy and complete the following table, finding the derivative of f by direct differentiation. Okay, so here we know the derivative of x squared is 2x. Here we've got u of x is x, v of x is x. In order to make this look like f of x equals u of x times v of x. Okay. So that would be x times x, which is our x squared over here. Derivative of u is 1, derivative of v is 1. Now let's do what they're asking here. Derivative of u, which is 1, multiplied by v, which is x, plus u, which was x, multiplied by the derivative of v. Now notice that this equals x plus x, which equals 2x. And that does equal the derivative that's over here. Okay, so we may be coming up with a rule here. the derivative of x to the power of 3 over 2, 3 over 2x to the power of 1/2. There's u of x, there's v of x. Derivative of u is 1. Derivative of v is 1/2 x to the power of negative 1/2. And then when we take a look at this, we've got u dash of x, derivative of u, which is 1, multiplied by v, which is root x, x to the power of 1/2, plus u, which is x, multiplied by the derivative of v, which is the 1/2, x to the power of negative 1/2. And when we combine these, this is the same as x to the power of 1/2 plus 1/2. Now we have an x to the power of 1 here, x to the power of negative 1/2 here. We're multiplying, so we add the exponent. So x to the power of 1/2. So we've got 1/2 x to the power of 1/2 and a full x to the power of 1/2. So 3/2 x to the power of 1/2, which happens to be the same thing we have right here. Excellent. Okay, now we can continue this down. I'm going to take it to a bigger piece of paper on the smartboard. Okay, I don't have enough room here anymore. The function was f of x equals x plus 1, which is the same as x squared plus x. And we know that we can take the derivative of that, 2x plus 1. If we let u of x equal the x and v of x equals the x plus 1, then we can take the derivative of u, which is 1, the derivative of v, which is also 1, and then from this formula, derivative of x times v plus, derivative of u times v plus u times the derivative of v should equal the derivative of f. So let's do it. We've got 1 multiplied by v, which is x plus 1, plus u, which is x, multiplied by the derivative of v, which is 1. So x plus 1 plus x, 2x plus 1. And yes, it works. All right, and the last one was the function is x subtract 1 multiplied by 2 subtract x squared. Okay, if we FOIL this out, we will have 2x subtract x cubed subtract 2 plus x squared. Combine our like terms if there is any, which there isn't, but I'm going to put it in this order. And therefore I know the derivative is negative 3x squared plus 2x plus 2 and plus 0, but we don't need to write it. All right, so if u of x is the first part, x minus 1. In other words, remember we're making this look like this. So u of x equals x minus 1, therefore the derivative of that would be 1. V of x equals 2 subtract x squared, therefore the derivative of that is negative 2x. Formula. And fill in what we know. We've already calculated everything. 1, 2 subtract x squared plus x subtract 1, negative 2x. And simplify. Minus 2x squared plus 2x. which is and subtract 3x squared plus 2x plus 2, same as this answer up here. So you've guessed it. This is the product rule. Right here. That is the product rule.